Welcome. Thank you so much for being here. This is a Google NYC TechTalk series event. So we've been running this series since 2010 to highlight the latest innovations from Google NYC. So thank you all for coming out tonight on your Monday night. We're really glad you can join us. And also, we're really glad that you're able to join us after the marathon. Did anyone run it yesterday? No? Okay. I didn't run it, but my boyfriend did, and I'm very glad it's over. It's actually stressful being someone who has to watch it. My name is Kimberly Kelly, and I'm a solutions lead here on the Google Cloud team. I've been at Google, actually Google Cloud, for 3.5 years. Prior to Google, I worked at Salesforce, at startups. I've done a mixture of sales as well as management roles here in the US and South America, as well as in APAC. I lived in Sydney, which is my favorite country in the world, or city, I should say. But today, we're going to hear from 3 Googlers on their latest cloud projects. And after all 3 talks, the speakers will join me back on stage for a Q&A. So you'll be able to get some of your questions answered. And we'll close the event tonight with a celebratory reception where you can have some drinks and snacks and some activities as well. Before we get started, let's go over some logistics. Please feel free to use our Wi-Fi. It's called Google Guest. There's no password that's required. We also have restrooms right outside to your left. You just walk straight ahead and they're on your left. And if you have any questions or need to use a parent's or prayer room, please just ask someone who's wearing a Google t-shirt and they can help you out. And finally, you may notice that we're using our newer Google Slides feature, and this event is being live captioned thanks to machine learning. So hopefully it'll make the event more accessible to all. So now why we're here. Tonight we're going to learn about some of the latest developments for Google Cloud. But let's start from the beginning and understand what cloud really is. When I say Google, this is probably what comes to your mind, a simple search box. But when I look at that screen, I don't really see just a search box. I see something that looks a little bit more like this. So I see all of the infrastructure that makes those wonderfully simple experiences possible, the ones that you have today. And it's only by investing in that infrastructure that you see on this picture that we're able to make all of the products possible for you to use. So I want you to all take a moment and imagine it's 1998 and you're trying to index the entire World Wide Web. What kind of database is up to that type of challenge is a question you may ask, or thinking around what it takes to index the web is usually things like storing multiple copies of the entire web. So what kind of file system is able to do that? So as our users grew, we had to figure out how to manage computers at scale. And solving these challenges required us to build the world's best infrastructure. And when I say infrastructure, you probably think servers. And yes, infrastructure does mean things like hardware, but it also means things like software, network, operations. All of those are required to build and operate at scale. But you don't have to build Gmail or YouTube to face all those kinds of problems we had to deal with in building Google all those years ago. And being data-driven is core to Google and how we operate. And it's increasingly important to any business we see today. And as Google grew, we needed ways to tie together engineering and product teams around the world to make them more productive. So just like you, we had to build systems that are resilient so that they can face all the types of complexities and security threats that every company faces today. So Google Cloud is designed to deal with those types of challenges by leveraging our technology, our infrastructure, our operations, our expertise, really how we innovate, is what's powering all of the tools that you probably use today, some or all. And today, Google Cloud has 9 products with 1 billion users each. So what we're going to hear from our speakers today is we're going to learn a little bit more about what they are and how we use them. First, I'd like to introduce Ajay Surie, who is the product lead for Google Voice and Hangouts Meets. He's the founding PM for the effort to bring Google Voice to G Suite. And prior to Google Voice, he led the launch of App Maker, which is G Suite's low-code app development solution. And he was the lead product manager for Google Slides since its launch, so what we're using today. And worked on initiatives across the Google Docs editors and Google Drive, including revamping accessibility, building offline editing, which I'm sure a bunch of you use that today, and enhancing sharing and collaboration. And before joining G Suite, Ajay was a product manager for DoubleClick for publishers and a software engineer on Google Maps. Ajay earned his bachelor's and master's degrees in computer science from Carnegie Mellon. And outside of work, he's an avid runner and amateur pilot. So Ajay, please join us up here.
Thanks, Kimberly. So my name is Ajay, as you heard. Today what I want to tell you a story about an internal startup, and I think you can guess what it's about. But before we get into the details about Google Voice, I wanted to talk to you a little bit about our product philosophy and how we develop products in G Suite. So this is the story of Gmail. When we've used Gmail internally for a long time. And message delivery has happened since the beginning of time. We started with maybe messenger pigeons back in the day. Mail delivery has moved to vehicles, now trains, planes, and automobiles. And Gmail has made mail delivery easy, fast, and from a storage perspective, unlimited. And then moving on as G Suite has developed, coming to calendar. So how many of you have a wall calendar in your house? Wall calendar is pretty popular. And then that's moved to people are used to carrying around planners when you go to meetings, and you have your daily diary where you can write stuff off. And with Google Calendar, what we've taken is those physical pieces of things that you use to plan your day. We've taken that and put that in your pocket, so you can have something that's with you at all times. It reminds you and tells you what you need to do, and you can share it with your family or colleagues. And then similarly with data storage. Data storage has evolved over the years. It started with storing a small amount of data, and we've scaled up over time. And with Drive, we've built a place where you can get unlimited storage in the cloud, have it be accessible from anywhere. And no matter if you spill coffee on it or anything, we've eliminated that problem, so your data is always safe. So we were thinking about new problems to solve in G Suite. What are problems that we can solve that would have a similar kind of impact? And we started looking at a bunch of different spaces to where we could dive in. How many of you remember these phone booths all over the city? We turned them, I think we turned some of them into these Wi-Fi kiosks, but they're mostly gone. But we still use phones today to communicate with our friends, with our family, with our colleagues. And there are actually over 8 billion phone numbers in the world today, which is actually more than the number of people. So it's still a pretty universal way to connect. How many people know what this is? Any guesses? Yeah, it's I heard server farm and phone switches. This is a picture of an actual phone room at Google. And we used to run a lot of them, and we discovered that they're actually, one, they're expensive. They take up a lot of space, not to mention cooling, and they're a headache to manage. So we pitched the idea of modernizing telephony and trying to get rid of some of these phone rooms to Diane Green, who was then the CEO of Google Cloud. And the way we went about this, we talked to a lot of customers. I actually talked to dozens of customers to try to figure out what they needed. And we learned that they had a lot of similar problems to what we had in G Suite. And we also talked to a lot of experts. So at Google, we are lucky that we usually have people who have worked in a lot of different areas. So one of our lawyers that we worked with for a long time was a former general counsel for the FCC. So we had all this expertise, and we were able to learn what we would need to build a product like this. So we concluded that it was a large opportunity. There was a lot of customers that we talked to that wanted it. Phone rooms like the one you just saw suck. And we had the assets to build a product. So one of the interesting things that people don't realize when it comes to telephony is Google has actually been doing this for almost a decade. So we've built, besides Google Voice, we've built a mobile carrier called Google Fi. We launched a product called Fiber Phone, which gives you home phone service. And we use telephony a lot in our ads products. So all of this is powered by, you guessed it, cloud. So we have a lot of country coverage and a lot of carrier partners that carry all this telephony traffic. And we actually have billions of call minutes and messages that go over this network. And then we have Google Voice. So for those of you who haven't used Google Voice, it's been a product that came out of an acquisition of a company called Grand Central that we bought almost over 10 years ago now. And we have a lot of millions of users who love the product. So as a foundation to build a business-focused product, we had a pretty good base to build on. So we pitched the idea of doing this, and we got the green light from Diane, and we went to work. One of the things we obsessed over as we were building this product was how would we go about building the right team to take on this project. So we started with an initial team. Our Google Voice team was based in California, but we needed to hire a lot of product managers, hire a lot of engineers, hire a lot of UX designers. How do we get the right team in place to build a product like this? So we realized Google has an office in Waterloo, Canada, and we realized a lot of people who had worked in the telephony space were actually located there. So we expanded our office to Waterloo, and we got the team in place. And we had a lot of stuff to build. So Google Voice, even though it's a 10-year-old product, as a product for end users, it offers a lot of calling features. It's got voicemail transcription and the ability to configure your phone in different ways. But for a business deploying phone numbers to each employee, it was missing a lot of the management features. So being able to assign people phone numbers, being able to port in phone numbers, advanced calling features, all of these features were not really in the product. So when we were starting the project, this seemed like a long list of things to do. So we tried to break it up into manageable chunks. So this is kind of like a high-level look at how we were thinking about the project. And we wanted to accomplish two things with breaking the project up. One was just to get the team to think in focused chunks of functionality so that we could have intermediate milestones that they could focus on. And then also, as we were testing the product and bringing it to market, we would get feedback from our customers and be able to adjust if needed. So this was broadly three buckets. One was a small test with a handful of customers, which we call alpha, and then a scaled beta with hundreds of customers before we ended up launching. So we got to an alpha launch very fast. We started, I think, in April of 2017, and within 6 months, we had a first alpha. And it was pretty minimal. It was really the definition of what you would call minimal. And we tested it with 2 customers that we had recruited that were excited about what we were building and wanted to volunteer to give us feedback. So all we had was a basic management experience that would allow a customer to assign phone numbers to their employees, and then an experience for end users to be able to hook up their phone number and use it with that managed experience. And the benefits were we got the product out fast, customers gave us quick feedback, and then we were able to quickly release incremental features to that same customer set. Along the way, we had to solve a lot of hard problems with Google Tech. And so this is just a couple of examples. So the first is we took Google Voice, which is a US-only product, and we took it to another 10 countries. And one of the challenges with working with our carrier partners in different countries is you have to validate addresses in order to make sure they're correctly parsed for having an address on file for emergency dialing. So of course we solved this with Google Maps. We give users a similar experience to what you might see. We validate the address, and we're able to hide some of that complexity from our end users. And related to emergency dialing, the other problem is what do you do to support emergency dialing across regions? So in the US, when you dial 911, a lot of things happen to get emergency services over to a user in trouble. And in Europe, they have a similar system. It's actually 112. But what we had to solve for how do we give a consistent, transparent experience to people who are moving across regions? So you can see in this case, we had to help users navigate that transition, which is even more complicated when people are moving around. And then along with the basics, what we wanted to do was look across what we had built at Google and take some of these technologies that we have pioneered and built into different products and build this into Google Voice. So one of the newest enterprise features, which is probably familiar to most people in this audience, even though you might not be familiar with the technical word, when you call a business their main phone number, typically you're directed to a menu where you can press 1 to dial sales or 2 to leave a voicemail. And normally, if you think about how someone might build that feature or how a business might configure that, you might have someone come in, record some audio prompts. If you're internationalizing it, you've got multiple offices. You've got to translate that audio. We had an instance where we had some audio prompts recorded in the Google Voice product, and the person who recorded the prompts had left the company. So we wanted to think about how we could use our technology to solve this. So naturally, we use text-to-speech. So in Google Voice today, all a user has to do is come in and type out the prompts, and we're able to verbalize it using that natural sounding voice that you might be familiar with, the Google Assistant. And Voice had already been using existing technologies. We have voicemail transcription, which is speech-to-text based, and we also use machine learning to solve the spam problem. Not fully solved, but some FCC reports say that over 50% of US calls are spam, and we wanted to start tackling that problem. So in Voice today, when we think a call is spam, we actually automatically send it to voicemail with a user experience that's very similar to Gmail. So we went through a long period of alpha where we tested the product with external customers, and then we went to a larger beta where now we had most of the basics of the product in, but we wanted a scaled test with a few hundred customers. So we announced that and launched that at Cloud Next. You can see me and my manager there on stage. And but we had one big thing that was still missing before we could launch to what we call general availability. And during the beta and the alpha, we had been giving the product away for free. And so most of you know, if you've ever built an e-commerce product or had to use payments or billing, it's very, very complicated. Billing is a pain. It's hard to build. And it's not actually that much easier at Google. So with telecom, it's even more complicated. If you've ever looked at your cell phone bill, you might see things like Universal Service Fund in the US or 911 fee. And so we had to actually navigate all that complexity to figure out how we actually understand how to calculate all that. It's actually jurisdiction-based in the US, and also integrate that into our payments platform, which is actually a layer that all of Google uses to bill, but wasn't really designed for telecom. So we had to address all these things you're seeing in order to launch. So I've given you a bit of a look at how we got here, but we just have a quick video that shows you a little bit about the product itself and gives you a flavor for how we think about it. And then I'll hand off to Brian. We hit play. Oh, I need to hit it. All right.
The new Google Voice for G Suite is smart and puts you in control. It follows Google Calendar's working hours, while powerful AI automatically transcribes voicemails and minimizes interruptions by silently blocking unwanted spam calls. And it works wherever you do, on desk phones, smartphones, and computers. And Voice grows with your business. Admins add new users and assign numbers to one person or an entire department with just a few clicks. Users can tailor the Voice apps across personal phones and work devices so they stay connected and in control from anywhere. And Voice keeps things simple. When you get a call from Hangouts Meet, you can see what meeting is calling and be ready when you answer. And when it's time to unwind, you're still in control. Because sometimes disconnecting is the best way to connect.
That was very cool. Thank you. Yeah, give him a round of applause. Thank you so much for that, Ajay. As a reminder, you will get a chance to ask him all about his talk in our panel after we hear from other two Googlers. Now I'd like to introduce Brian Sook, who I've known for quite a long time. He's a solutions architect for Google Cloud, and previously was a big data specialist. And prior to Google, he was a data and analytics solutions engineer at SAP and a solutions engineer at Informatica. Brian has helped a diverse group of customers overcome some of their toughest data challenges for over a decade. And now he's passionate about applying the best of Google's data engineering tools to build impactful solutions. So Brian, please welcome yourself.
Thanks. Good evening, New York. How you all doing? Nice. Good to hear it. Again, thank you all for the time tonight. I know it's a Monday evening and you chose to spend it with us, so definitely big welcome to our campus, and we do appreciate you coming. So my name is Brian Sook, and as Kim mentioned, I'm a solutions architect and with the cloud team, and our team is a customer-facing team, and so we work with people who want to move to Google Cloud and leverage our technologies to build solutions. And to put it at a high level, the easiest way to explain it is our job is to make cloud easier. And it comes with a number of different challenges because the cloud platform here at Google has developed very quickly and very rapidly. And so personally, I have joined in 2016. As Kim mentioned, I came from SAP. And back when I joined in 2016, the list of products in the platform wasn't this small, but it was a little bit bigger, but it still wasn't that much bigger than this. And the point I want to make, though, is especially when we're trying to make cloud easier, it gets a lot more complicated when we fast forward to today. And this is the offering at a very quick glance of all the different components and all the different tools that you all have at your disposal when leveraging the Google Cloud Platform. Now, for me, I am a data junkie. There's a lot of different things you can do, ranging from machine learning to application building to managing security, infrastructure, and the list goes on and on and on. But for me, I'm most comfortable and I'm happiest when I'm looking at a console writing SQL. And so my main focus is on the data engineering team within our group, and I just want to give you a glimpse into what we focus on. And so at a quick glance, these are the different components of our data and analytics platform. And it ranges from a number of different components, all the way from very fast in-memory caches to large data warehousing applications, and everywhere in between for all different types of data stores. Now, what I really want to focus on a little bit more today is the one on the far right where it says BigQuery, because that's really what gets me excited, and it's my favorite tool out of all of them. Now, BigQuery is a very, very interesting tool in that it is a fully managed, fully serverless data warehousing platform that completely separates out compute from storage. And everything happens as a fully managed service as well. So everything from data ingestion to encryption storage, maintaining that SLA for resiliency, availability of data all across the globe is all just an SLA that you pay for, and everything else in between goes away. And so I come from a background prior to Google where I used to work with a lot of different on-premises data appliances. And so literally contacting a hardware provider, waiting for that box to come in on a shipping pallet, and then racking and stacking it into a data center, and then getting to the point after that where you can finally get into a console and then start to install software and maybe one day be fast enough to ever load data into it, right? Where I became fascinated with BigQuery upon joining Google is the fact that I can just take my data, load it into a bucket, a storage bucket of some sort. I can tell BigQuery, here's where it is, here's where my schema, and you're off to the races you go. Now, you can probably tell there's a little bit of detail within there, but generally that's the overall workflow that you have. And so everything ranging from provisioning virtual machines, trying to figure out how much storage you need to provision, all that goes away, and it becomes a fully elastic managed service. And we're extending that into broader different use cases and different applications. And this is where it also gets very, very cool, because I remember the days when you had a SQL engine, and let's say you wanted to do geospatial analytics on top of that, you typically had to export that out into a separate geospatial system, do your geospatial calculations, put that back into your database, and then try to merge it back together. There are some technologies out there that have started to merge geospatial and relational data into a single unit. However, you still are bounded by the physical server and thus the compute power and the storage capacity of that particular piece of infrastructure. So while it may get you the features you want, once you start having more and more data, you start to tap out, and then your system it hits its limit. What we started doing is looking at our infrastructure and our platform and saying, look, if we have a warehousing platform that is fully elastic and it can scale as little or as large as you need to with little to no maintenance, then why don't we start bringing those particular pieces of computation to where the warehousing and the storage is? So one of the first things that we did was introduce geospatial capabilities into the BigQuery platform. And this is pretty cool because now you get to leverage a lot of the horsepower and the flexibility of this particular piece of technology and start to do geospatial calculations as well. So for instance, if you're working with retail data and you have store performance information that's going to be in tabular format, previously, if you wanted to do store planning or look at this on a map, you had to pre-calculate all those different latitudes and longitudes, and you had to create different polygons beforehand, and you had to be bounded by the particular different geographies that you have. But now you can start looking at it from a purely mapping perspective and say, what will be the population within X kilometers of a particular point, and then merge that with your sales data and start to optimize and do route planning on that kind of stuff, right? And again, this consolidation of infrastructure and technology bits is what really lets people flexibly query their data. Now, if you've ever been to a different Google presentation, you've almost definitely heard that we are now an AI and machine learning first company. And this is true all across the 9 different products that we have that are 1 billion users plus, as well as a lot of the cloud platform and the capabilities we bring there. And BigQuery is no exception to that. And so what we've gone ahead and done here is, in the same SQL context, be able to do predictive analytics and machine learning on your tabular data without having to export that data into a different predictive engine and then do that calculation offsite and then bring that back on. And again, the scalability and the ease of use all gets wrapped into the same one. Now, one of the things that I think is super, super cool about this, though, is the fact that this is all in one house. And so now we have traditional warehousing capabilities, we have geospatial capabilities, and we have machine learning capabilities all in one place. And so what happens if all this comes together and you start to use it together? And instead of just talking about all this, I want to break out of slideware for a little bit and actually show you what that looks like for a couple minutes. So if we could switch back to the laptop. Perfect. So what you're looking at here is our web interface to BigQuery. Now, right now you're looking at a blank screen, but if you've ever worked with a database, it's probably starting to look a little familiar, where you have your data sets on the left side, you have some sort of query window where you can write things, and then you have results on the bottom. And I'm going to walk you through a couple different steps on how machine learning and geospatial can play together. And so when we think about the machine learning workflow, there's a few different steps that you have to take. At a high level, the big three steps are prepare your data for training. You want to create the model on top of that, and then you want to predict on top of that. And so what we're doing here is we are going to run a simple query, which is going to create a table based off of publicly available New York taxi cab information and start to do a little bit of data quality. We're starting to just minimize the number of columns that we're interested in. And we're creating, if you look up top, we're just creating a replacing the table for our feature engineering data set. Now, the actual specifics of the SQL query are not important, but the important part is the fact that this is all SQL 2011 compliant syntax. So if you know how to use any other database, you're already about 90% there to already being able to use BigQuery. So the learning curve is very, very low if you're familiar with any other database. What I then want to do is I want to create a model. I'm going to show you what the syntax looks like for that. And what this is doing right here is this is going to take the information, if we're going to do the select clause down here, and this is simply taking taking the million rows that we've created in that new different table. And the cool part about this, though, is if we want to create a linear regression model, it's quite simply these two lines up here. Let me make that a little bit bigger. And what we are telling it is quite simply create or replace a model. We're going to give it a name. And if you see, if you see in the second line of that text, it's going to say the fair amount is what we want to really be the predictor. And the model type is going to be a linear regression. There are a number of different models that we have introduced into this as built-in functions. And we also have introduced the capability to leverage TensorFlow models within BigQuery as well. So if you're a machine learning programmer, you're a data scientist, and you're familiar with TensorFlow, you can now embed that into BigQuery, which is super, super cool. One of the key points to take away here, though, is that we're not forcing you to learn or understand all the data science and magic behind it. If you are a developer, if you're a database developer, you now have the capability to start to train and deploy predictive models right within the same SQL environment that you and I are all familiar with. Right? So I run this right before the session started because I didn't want you staring at that for a little bit. It runs in about 3 minutes, trains on 1 million rows, and it outputs this particular model right here. And on the left side of the data set, where typically you would see just tables in different schemas, in our environment, the first one up top where it says feature engineering training data, that represents a physical data table. And right under that is the object which represents our machine learning model that we've deployed onto there. So the next step that's naturally going to come out of this is we want to predict on something. So let me load that up and show you what that looks like. Now I'm going to highlight the bulk of this here. And what we are doing here is we're not selecting from a full table yet, and we're not feeding entire tables worth of data. But what we are doing is we are just simply defining latitudes and longitudes. So the context behind this particular model is we have a number of different public data sets that are out there. We have a number of different partnerships with third-party agencies, and we have that we maintain relationships that you can use the data for. And one of them is with the New York Taxi and Limousine Commission. So the data that we source from and that we created the linear regression model on top of is years and years of historical taxi fare data that the TLC has collected. Now, upon that data, we we fed it different features such as the pickup latitude, longitude, the drop-off latitude, longitude, things such as time of day, the number of passengers in the car, and the fare that was observed. And then we use that to train the model and then predict what the fare is going to be. And so what you're looking at here in that select statement is we are giving it a pickup latitude, longitude. We're giving it a drop-off latitude, longitude. We're giving it number of passengers and time of day. Now that's just standard, regular database SQL things that everyone's used to. But the cool thing is in order to take advantage of machine learning, all it takes is that one line up there, which says select all the results from the ml.predict function. Then you feed it that particular training model that we gave it, and then it's going to be able to incorporate that prediction into your result. So if I run that, now it's telling me that for that particular set of pickup and drop-off lat longs, it's going to predict that the fare for that particular set of parameters will be about $7 for that particular fare, right? Now this is where we started feeding it. If you think about it, it's going to be tabular data. We're feeding it geospatial coordinates and geospatial functions as part of the training data set. And now we're predicting on not only tabular data, but also geospatial data sets. The next thing you'll probably want to do is visualize it. And with here, I'm going to feed it two of them. So instead of, we're doing the exact same thing as before, but instead of force feeding it one set of coordinates, we're going to give it two. So now it's going to be our little mini data set. And the point of doing this, though, is to illustrate that not only can you do it on individual records, but you can do it on entire tables. And with the scalability of this platform, this means you can do it on 1 row, 2 rows, 1 million rows, 10 million rows, and it'll just churn through it as fast as it possibly can, right? We now have two different coordinates, one that's predicting $9 and one $7. And so what I'm going to do is I'm going to look at this on a map. So as part of this particular capability, demo, I can't talk and type at the same time. I can specify my project. As part of this particular capability, we introduced two different things. One of them is additional API functionality and SQL syntaxes that allow you to interact with that with whatever third-party tool, visualization, business intelligence tool that you are familiar with. Or you can use this thing that we've launched called BigQuery GeoViz, which is a lightweight tool designed for prototyping and just kind of quick checking, is my query right? Am I on the right track or am I not? And so if I run that same query within this interface, you now see, and this is just something I came up with about 30 minutes ago, so there's not that many data points on it, but it is those two different sets of coordinates that we have. So these are two different routes, start to finish, and it's going to represent the taxi start and end. And what I'm going to do here is show you that you can also stylize the map, so you can start to differentiate between the different ones. And I'm just going to do a quick, let's go with stroke weight. And make that data-driven, linear. And I'm going to do this upon the predicted fare amount. Minimum is $7, and we'll make that 10, and then 1, 10. And so now you can quickly, interactively start to stylize the different objects you have on your map. Now, things such as points, polygons, lines, all the different geospatial types are supported. So whatever your data is going to output, you can start to visualize it very quickly and see what's what. One thing I will also mention that's pretty cool is all this is made possible by our public data sets. And so we have, I mentioned earlier that we have a number of different partnerships ranging from different government agencies, the partnership with NOAA that we have, the National Oceanographic, I forget what the 2A stand for, but they're the ones that provide the weather data all across the US. Those are popular ones, so you can start to leverage a lot of the data sets that we help curate, make public, and then you can start to merge that with your own data, which is pretty cool. And go back to the slides, please. So hopefully that gives you a little bit of glimpse into what the platform looks like. And I just wanted to show that to you because A, I think it's just my inner tech geek that's really excited about that. And I think it's super, super cool. And B, just sort of in our day-to-day life and what we do, these are the tools that we use frequently every day. I just kind of wanted to let you see what that looks like. Now, in case you are so inclined and you really want to start to play around with it and you think it's as cool as I do, there are a number of different things that you can do to quickly bootstrap your knowledge upon the platform. The bottom two are pointing to tutorials for both geospatial capabilities and machine learning, but the top one's what I also want to call out, which is the BigQuery sandbox. No credit card, no problem. You don't have to sign up for an account. You don't have to create a new cloud platform account. You don't have to input a credit card or anything like that. It does provision a small sandbox with full capability so you can sort of test things out and see what it looks like. And it's a very, very quick way to be able to stand up and just kind of write queries and see what happens. And with that, there also are a number of different ways that you can say hello, whether it's going to be through something like Stack Overflow, Reddit, or I'm also on Twitter, so if you want to tweet at me, you can do that too. But again, that's sort of the BigQuery platform in a nutshell, and it's a little bit of a sneak peek, and hopefully it's given you some new ideas in data processing, and hopefully you all found it as cool as I do. So with that, I'm going to hand it back to Kim, and thank you again. Appreciate your time, and yeah, awesome.
Thank you so much, Brian. I'm very visual, so I love a demo. Now for our final speaker, please welcome Anu. She's a developer program engineer for G Suite, and she advocates for developers building on top of G Suite to enhance their business, and I'll let her continue on from there.
Cool, thank you. Hi, everyone. My name is Srivastava. I've been at Google for almost 6 years. I started out as a software engineer in cloud infrastructure, and that actually led me to G Suite. Google Cloud is both GCP and G Suite, so today I'm going to show you how to use both of those together to solve real-world, tangible problems. So we're going to look at serverless computing specifically, and then tying it in together with the G Suite applications that you might be using today already. So what are we going to do today? We're going to be talking about how serverless technology allows you to focus on your code and not the underlying infrastructure. You know, if you work at a media company, your focus is on creating. If you're working in education, your focus is on teaching. We don't just spin up servers and put people on call just for the fun of it. Everything we do is for a reason. So I'm going to go a little silly. We're going to go through a fictional story dealing with Alice and Bob. And if you've heard of Alice and Bob and technology stories before, they're normally doing things in like cryptography, doing secret message passaging. Well, it's the new millennium, and now they run a brick and mortar shoe store. So it's a small operation. They get to manage their sale prices in-house. The employees involved with shipments do basic inventory management in Google Sheets. They do things like track the names of the shoes, the prices, whether it's in stock or back in the warehouse, vendor information. If they can get the information from a website, they store it there. If not, maybe they just make a Google Doc with all that information. Well, they want to be more modern. They want to give the employees phones and tablets to use on the store floor. This is actually something that happened to me when I was working retail in high school. There's a lot of wasted time during sales or with the stores really crowded with customers. They need to be able to get the latest availability and vendor information without having to run back and forth. Well, the problem that we have here is that this isn't really as usable as you'd hope mobile right out of the box. It's a little bit difficult to manipulate. If the store is busy, we don't want people kind of having to mess around with those devices or needing to, like I said, run back and forth. So Alice and Bob are close, but this doesn't quite solve their workflow problem just yet. So they want to prototype a better way to do this. Well, with just a little bit of JavaScript, a little bit of schools online, they prototyped this UI for a mobile-friendly web app. They don't want to sit down and crash course on Android or iOS development. So this is simple to get up running in an afternoon. They want to see how this works before fully investing in a solution. So where to start? How do they actually host this and serve this? So they need a backend now. And if you do some research into what a typical architecture looks like, it's not just client and server. If they want things that we like in operating systems, such as like fault tolerance, high availability, when they have multiple servers, maybe they need a load balancer. If they have a database, maybe they need a cache. So first they'd have to set all of this up, and then they'd actually have to maintain all of this, which is a lot of work when you just want to get something up and running pretty quickly. If they go into the cloud, the traditional way, there's still a lot of setup that they need to do for their VMs. They don't have to manage the physical machines themselves, but they do have to know everything that's going on top of them and, making sure that they're in sync. You'd also need to think about, things like handling spikes in traffic. You don't want too many idle machines, how to use their billing most effectively. They really just want to focus on their code that matters to them. So there's got to be a simpler way to do this. And this is how we get to serverless. So with serverless, you upload focused code, and then your cloud provider figures out how to place and scale it and manage it for you. With serverless, you are giving up a little bit of that fine-grained control, but you're really gaining a lot for ease of management. The specific serverless product that we're going to be looking at today is Cloud Functions. The most famous one in the serverless portfolio is App Engine. Has anyone heard of App Engine or used it before? Awesome. Well, Cloud Functions is a bit newer. Cloud Functions is really for more narrow, focused bits of code to Google, and then GCP will figure out how to place and scale those individual functions for you. And you trigger them by events. Today, we'll be looking specifically at HTTP of functions. You can write in Java, Node, Go, Python, and there's some beta languages already up. So that's the GCP side of things. Now let's talk about G Suite. So in G Suite, we have APIs for all these products that maybe you're using today, such as Calendar, Gmail, Google Docs launched earlier this year. Today, we'll be working with the Sheets API. So let's look at a code snippet of actually working with Sheets. You can see at the bottom where we are actually pulling out those fields that we know that we need. We need to know the shoe, we need to know the price, the status, the image, and all that type of stuff. If you want the full working code for this demo, it is up on GitHub. So for serving the HTML, JavaScript, CSS front end that we saw, we need something to actually serve that. And this is the Cloud Function that we're talking about. They could serve it from a client, or they can actually go the Cloud Function route and deploy it to GCP. And when I keep saying the word function, it is literally just a function. Like with basically 3 lines of code, they have a fully functioning backend. So this just calls the code that we saw on the slide earlier. You can manage functions in the Cloud Console, which we saw a little bit of earlier in the last talk with BigQuery. You can even edit the code right there in the browser. You get nice things like syntax highlighting, upload multiple files like package.json, because we're working with Node here. It's good for quick fixes, but I do find it easier to develop in your own environment on your laptop or desktop. So we deploy that function, and we mentioned that this is HTTP based. So when you deploy to Google Cloud Functions, it gives you a fully provisioned HTTP endpoint with a bit of security on top of it. And that's what it actually looks like if you were to go to the browser and see how that code is pulling out that data from the sheet and serving the JSON right there. So we transform that data to JSON. And now we can actually serve this front end. So every time a store employee goes to their internal site, they can get that inventory data right at their fingertips. No more extra trips between the stock room and the store floor. With really only 30 lines of code, they have a complete functioning backend. The inventory function handles everything they need on the server side. And remember that this is our inventory cloud function, and then now we'll see what enhancements they might want to make this more scalable. So the prototype is working. They really like it. It's making things a lot more efficient. They can deal with customers more quickly, and everyone's happy. So they want to make this more future-proof, more reliable. There's lots of different enhancements that you can do on a system like this with other GCP or G Suite products, but the first thing that they probably want to do is add a database. Sheets is great for collaboration and doing the functions that you do as a sheet, but if you want something that is more sturdy, you're going to need to use a database. So luckily, another database in the GCP portfolio is Cloud SQL. It is also SQL-based, looks very simple too. If you do MySQL or Postgres, you actually just put that in the cloud and GCP will handle that for you. So we want to break up this into two different parts. We still have inventory, which is actually serving that data, but now we want to get the data that's in the sheet into the database. We don't want to remove the sheet from the equation because it's easy to use for people of different backgrounds, and we want to use it as like our input, as our UI. We're really turning the sheet into the application. So we add a second cloud function that inserts those rows from the sheet into a database. And we want to call it start export. But how do the people inputting the data actually kick it off? Well, you can actually do cool things with AppScript right in the sheet itself. So how do we get this cool custom menu? And I mentioned AppScript. So AppScript is a variation of JavaScript with built-in libraries for G Suite. And one of the cool things about using AppScript as opposed to another language is that you can directly integrate into your G Suite products. So we saw how you could integrate into Sheets, and that works in many other G Suite projects as well. How do we actually do this? You can actually write AppScript and get to the code editor right through the sheet itself in the script editor. So this is what the script editor looks like. We added a second Google Cloud function with an HTTP endpoint, and all we have to do is stick it right in there and then call it every time someone hits that menu item. And that's how we have now a two-part system with a reliable database that actually serves that web client. Our diagram is having more parts, and there's many other things you can add using the GCP portfolio. Maybe they want to add Cloud Vision, some machine learning. So you can think of Cloud Functions as a glue for gluing different parts of the system together. So Alice and Bob started with this. And now they have this. With just a few Google Cloud Functions, they can solve a real workflow in their day-to-day business operations. So now it is your turn. Here are some of the quick starts for getting started with the different products that we talked about today. The full working code is up on GitHub, and then feel free to tweet at me any questions you might have.
Oh, I think you can take that. Or testing.
I'll hold it.
Thank you so much, Anu. Now I just want everyone to give all the speakers a big round of applause. I'd actually love to welcome all of our speakers back to the stage as well. And if you have a question, please feel free to line up behind the mics there's one in each row here. So if the speakers, please join me. And for those of you that have questions, don't be shy. If you are, I have an icebreaker question. But I'll kick us off while we wait for those who want to line up. But first, I just want to ask our speakers a very quick question. And if you can all please respond. How would you describe your life at Google in 3 words? Brian, I'll let you go first.
Eat more snacks? No, it's probably solve cool problems. I think that's probably what it would more align with.
I'm going to use 4 words. I would say challenging, fun, and constantly changing.
I would actually say college, but better. We still do things like I feel like it's the sort of master's education of like critical thinking that you get to do, but you are paid to do so, and then you are paid to eat snacks. But we have, other aspects of college life, like their clubs. I know that there's like a lightsaber club. And then like for more academic oriented people, there's actually people who get together and read white papers to like understand what's happening in academia, and then we apply a lot of this experimentation into the code that we're writing.
Thank you.
100 words.
We'll start over here on the right. My right.
Very quick question for Ajay. So does this mean Google Voice is getting international SMS? I know it's hard.
We actually only have SMS in the US, even for the G Suite version of the product, but something we may consider for the future. Nothing to talk about yet, though.
So this is actually a concern I think I got from Joel Spolsky. So you describe all these cool platforms where you don't have to know anything, and there are layers and layers and layers of this stuff. But when something goes, and Joel's concern was that something could change, and the end user wouldn't even know about it, right? And would have no visibility or insight in it. So like something changes in one of these lower levels, and the user using this doesn't know anything about this. So one possibility is, okay, I call customer support, but now that customer support problem has the same kind of problem. There are all these layers and layers and layers. So it's really just a broad general question for all of you. How do you deal with when something goes wrong? What do people do? How do you, especially if you're on the outside, right, using this service? That's it. Thanks.
Does anyone want to volunteer and take that one?
I can start off with it. So I think there's many different ways to look at that particular question, and so on the Google Cloud Platform side, that's where I focus on. So I can only speak more on that end. But I think there's there's 2 aspects of development that we would probably look at it from. One of them is from the traditional infrastructure standpoint, and the other one is from the managed service standpoint. So again, if that kind of root level introspection and visibility is critical, and that's business critical, then there are options to use, commercial software that you can deploy on infrastructure that you can control, that you can see into, and do that root cause analysis. On the managed services side, the general product mentality is always to enhance and add, and not take away, but if you do take away, then do that in a controlled fashion. So what we want to avoid is we never want to be in the position where something breaks in an application on managed services and the user doesn't know why. That is the worst possible situation to be in. So this is where on the cloud side we definitely work with each and every customer that we engage with, and we make sure that it is a partnership. So if there are changes, that you are aware of it, that we can jointly plan for it. And just hopefully the changes will always be performance enhancements and added features, and everyone's happy.
To my other speakers, does anyone want to add to that?
Yeah, I can talk a little bit about the G Suite perspective. I think just 2 ways to think about it. One is internally, how do we look at our systems and develop on them? We use a lot of shared infrastructure, from stuff that Brian mentioned, to storage systems, to our telephony platform that I was talking about. So one, we try to make sure that our products that these platforms are generalized, and we have like well-defined interfaces to make sure that we are testing the integrations with these systems, because they are complex, as you mentioned. And the other thing we do is try to have multiple touch points for ways to get feedback. So just as an example, we have product forums where experts about the products you heard about can talk to other users. We regularly solicit user feedback through, you can, in any one of our G Suite products, you can leave you can leave feedback as an end user. And while we're not able to respond to every single user, we do look at this feedback in aggregate, and product teams will react to it and improve it. And we have ways to get that feedback back out to users. We hold forums for top experts to come in and learn from them. And then on the customer side, for all our products that businesses use, we do we frequently solicit customer feedback, because a lot of times they are like customers who buy our products from G Suite are the ones that interact with their users, and we also have customers who come to us and engage with our product teams to give us feedback. So we use a lot of these levers to connect with users and customers of our products.
Thank you. Let's go over here for the next question.
Perfect. Thank you very much for your presentations tonight. I wanted to ask you, Ajay, in particular, since Google Voice has been up and running for the past 10 years, what would you say the next 10 years are? Where is the boat heading? And where do you see voice coexisting in the marketplace with the likes of Verizon, AT&T, and globally Vodafone and other companies?
That's a lot to unpack, but I'll try to give you some. This is just these are all just my opinions. So I will say that I've been using, one of the reasons I wanted to work on the product was I'd been using it for 8 years before I actually even joined the product team. So I actually have a phone in my pocket that does not, all the people who have my phone number have my Google Voice number. So I switch back and forth between devices and make sure that people can reach me. But I think generally, the trends that you're seeing in the consumer space, if you look at products like Messenger and WhatsApp and the over-the-top messaging services that people use, people want to be able to switch between audio and video, and we need to, with voice in particular, we need to integrate it with these other products. And even though these over-the-top solutions exist, there are still times when you want to reach someone over the phone or over audio. If you're driving, you can't look at a screen. If you're in poor data coverage, you need sort of the phone network. But over time, I think the transport layer itself, how the communication is delivered, kind of abstracts away from the user. People just it's, do you want your camera on or off, and how do you switch between those modes seamlessly? So I think hopefully carriers will also are also latching onto that trend, and they're trying to give better experiences for users to be able to use the right mode of communication for the right time.
Thank you.
Thank you.
Thank you very much for presentations. Quick question, what was most unexpected thing during professional project execution in your life, and what would you suggest to avoid this in the future?
Ooh, that's a good question.
Good question, yeah.
Anna, do you want to take it?
Give me a couple times. I'll let one of y'all take it
Or
first.
Brian?
I think when dealing with cloud deployments, I think the one thing that I didn't expect going in was the cultural aspect of it. So when I joined about 3-4 years ago, we would walk around and we would say, okay, the technology's solid, it's built off of Google infrastructure, and the general pitch is that it's we've battle tested it and we've commercialized it, right? And that's what the cloud platform is. So why wouldn't you use it? And then I had quickly forgotten, coming here, my large enterprise background and the culture that comes with that. And I think the one thing that caught me off guard was, coming in with an architecture that's super cool, it's going to solve all your problems, and why wouldn't you adopt it? And there's a lot of cultural change and a lot of I think there's some level of trepidation on the user space about something that's this different and this new. And even if you're looking at one-to-one infrastructure, even just moving from an on-premises data center to cloud infrastructure, that in and of itself is also a fundamental change, right? So I think the change management part of it was something that at least I personally hadn't taken into account, and since then have gotten better at, thankfully. But that's that would be my response to that. Yep.
So I served on call actually while I was a traditional software engineer here for years, and no matter how big or small the company is, like things will break. And what I found like most unexpected is the level of trust and communication that we do have internally with each other, and you have to have that, and you have to work on it so you can prevent things like global outages and work through them together and make sure this really doesn't affect the customers that you have.
I had to just add on to what Brian said. I think it's really unexpected to just see what customers go through. We are very privileged at Google to be just around the best, some of the best technology, and we have an amazing a team that helps work on the technology we use internally, and we're kind of spoiled by that. But sometimes you just don't realize until you talk to customers like where they are. So you have to meet them where they are. And two examples I'll give you is when we were building this the voice product, we talked to a customer that told us that they get their phone bills on a CD, and I haven't had a CD drive in my machine for like years now, so not quite sure how we had to meet them where they were in terms of like what problems they were trying to solve. And then also we're just another similar unexpected thing that happened is, we have customers who use our video conferencing products, and a lot of them would complain about the bandwidth issues that they have because they're managing their network topology. And at Google we're sitting on top of like some of the this building sits on top of like the fiber optic cables coming into the network. So I think we only realized that we only had a taste of what customers were experiencing when this floor that you're sitting on, I think our CIO sits on this floor, and we realized that the network config on this floor was inadvertently, I think, 10 meg or 100 meg instead of a gigabit, and there's hundreds of people on this floor, and so they were complaining about bandwidth issues in meetings. And so until we sort of experienced that, we kind of got a taste of like what our customers experience. So I think meeting customers where they are in these situations is something that's surprised us and surprised me in the past, and something we've got to continue to do.
Thank you very much.
Thank you. Our next question, please.
Hi, thank you all for your time tonight. I had a quick question for Ajay on the Google Voice product. I started using it really early on. I was living abroad, and I thought, oh my God, this is great. I can have a US number for all my friends back home. So I always thought it was really good. But I was recently reading an article about Airbnb, and someone was trying to investigate fraudulent activity. And one of the indicators that they had that this was fraudulent was that the person they were communicating with had a Google Voice number. So it seems that there's a perception amongst consumers that if you have a Google Voice number, it's not as legitimate as some of those legacy carriers, Verizon, AT&T, for example, which seems like an interesting problem for Google, because when you talk about something like Gmail, you have the opposite problem, where if you're not using a Gmail address, everyone says, what's wrong with you? So it seems like this is maybe specific to Google Voice within the Google Suite. How are you handling that consumer perception that there's more legitimacy to those numbers that are associated with legacy carriers than some of those early adopters who are maybe not using it for the best purposes? Thanks.
That's a good question. I'll try to answer it in a couple parts. Generally, I think phone numbers in the U.S. the trustworthiness of phone numbers is dropping off across the board. So if you've received a spam call in the past, you might have seen, what's called neighborhood spoofing, where people try to change the last 4 digits of your phone number and to make it look like something you might want to pick up. So there's a lot of untrustworthiness in the phone system in general. With voice, we try to combat this by we try to make it a little bit harder for people to get numbers easily by verifying. When you get a new voice number, you have to verify it with a number you already have. But going forward, I think what we're trying to do is, one, work with our carrier partners to make sure that voice is perceived as a sort of a trustworthy service. And some of the things that the industry is doing is to combat spam is trying to sign caller ID. And you might have seen, you might have heard about this, initiative that Twilio is trying to do, where they can digitally, similar to the way you have certificates for websites, you might have a way to sign a caller ID. So this is it's a long-term thing that the major carriers in the U.S. are doing. It's a project. The acronym is STIR Shaken is the project that they're trying to do, and we're trying to work with carrier partners to sort of get that level of sort of authenticity for voice numbers as well. So it's not a quick fix, but something we're working with our partners across the industry to solve.
Thank you.
Thank you. Next question, please.
My question is actually related. First of all, thank you all for your time and your talks. But mine's also about the telephony space, and it's actually specifically about the spam space, because sometimes I'll have calls that are from area codes where I work with people like San Francisco or Chicago, and I have no idea. Occasionally it'll say like spam ? And then I'll ignore the call. But in the video, it seemed like the woman walking down the street had her spam call sent to voicemail, and I'm assuming no one left a voicemail at that voicemail. But I get spam calls in multiple languages on multiple phone lines, and I wanted to know how, since Google is such a large established company, like how you've worked with either some of the larger U.S. carriers or the FCC, or like it said something like you prevented 90 or 99% of spam calls, and that just sounded like astonishing to me, and I wanted to like unpack that a little. Does that make sense?
Mm-hmm. So what we do with the spam detection technology in voice, if your number is with us, we have a lot of data from users reporting calls that are spam. So the Android phone app, the phone app that ships with Android, our mobile carrier Google Fi, people are using our product and reporting when phone calls are spam. So we have a pretty good idea of, not a perfect idea, but we can detect pretty reliably when a call is spam, but we don't detect all spam calls. So if you think about precision and recall, our precision is pretty high, but our recall is not quite so high. So they're calls that we don't recognize as spam that we should. So when these reports that users give us some pattern detection, and that's what we use to train our models, similar to the way that Gmail does it, and that's how we're able to detect spam. So the user experience you saw in the video is how we built it the way we would have thought about spam in Gmail. So when we know reliably that a call is spam, we send it to voicemail. But your number has to be on our service for us to be able to intercept that and do something with a call. So if you're using one of the major carriers, they have their own spam detection systems, and they can kind of write, they can, if you're using, say, Verizon, they can say scam likely or something like that, but that's using their own detection. So there's no real industry standard for how to detect spam, but that's the previous person who asked the question. They're trying to figure something out that the industry can use.
So if I can just ask a quick follow-up, which is, do you guys still discontinue someone's number if they don't use it for a set period of time? Because I had my Google number taken from me because I didn't use it for like 6 months or something.
I believe we still do that. I don't remember the exact time frame off the top of my head, but we can point you to the right resources if you grab me afterwards.
Okay, thank you.
Thank you. Next question.
This is for Ajay. You mentioned the complexity of billing, and I'm intrigued with that. How do you source like tax data to make sure that when you do billing, it's the right billing?
It's a very good question. We rely on a partner to give us the data for most of the U.S. and Canada zip codes, and we trust that the data is. I mean, it's what a lot of providers do.
With so many new services being added to GCP, are there common themes along what your executives look at to determine if a service is being successful after launch? Are there any success criteria, or I'm sure just different from service to service, but are there any common themes that your executives are looking at?
Does anyone want to just jump at that?
Or are you just, I mean,
It might be a little bit above my pay grade.
What are you guys reporting internally on these services? Is it just like how many people are using them, or how?
So and I think this is true in most services. The general metadata you expect around any product, such as number of users, average usage, of course, revenue generated, things, the normal things you would kind of guess would be measured.
Right.
I would say on the cloud side, one of the key things that we do is we do hold. I forget what they call them, but generally we will take some of our biggest customers, the big logos, the large enterprise customers, and we will. The ones who volunteer for it, we will kind of put them in a room and say, all right, well, what's the feedback like? What are you using? What's not? What are you looking for next? And try to seek the customer's advice on where we should be taking it and take that feedback into the product design and the roadmap. So that's something that we do fairly regularly, and I think is a big indicator of where the products are going to go next. But.
Gotcha. And one last question is. Oh, sorry, I didn't mean to cut you off. You're going to answer that. Is Gmail ever going to become fast? Because I feel like it's still really bulky to this day. Thanks.
I don't know the answer to that.
Thank you. Our next question.
Right, thank you guys. Great presentation, and I love that live subtitles that's going on here. That's very rare to see. Although it is very accurate with some very pointed mistakes as well, but I guess that'll get better. Quick question for Brian. You mentioned something about how compute can be separated from data using BigQuery. But if you're separating compute from the data, that essentially you're separating the servers. Now, we're talking about petabytes of data, and as we all know, like if you're going to transfer petabytes of data over the internet, it's going to be months of parity checking. Are we still talking about solutions where we take hard drives and snowflakes and snowmobiles, basically take them to the data centers and then do the compute? Or have you guys come up with something really exciting and new that compresses the data or somehow transfers the data, or you somehow, you use lightning power to send the compute to the servers where the data is? And my question to Ajay is to do with your product, and this might sound a little grim, but don't you think the end goal of your product should be to be irrelevant, because you're basically dealing with backward compatibility, which is phones? Nobody really uses a smartphone anymore for a phone either. It shouldn't even be called a smartphone. It should probably be called a smart device. And eventually you want to move away from these 10-digit numbers into something more powerful. So do you think the end goal of your product is essentially to become as irrelevant as possible, and then just have something other like WhatsApp solution or Google Voice solution or Google Chat solution that takes over?
Do you want to go first? Or?
Either way, I'll let.
All right. I'm glad you asked that, and I'm going to rely on the crowd to keep me in check because I get really excited about this, and I will talk for about an hour if you don't stop me. So, the separation of compute and storage is pretty fascinating, because what we've done is we've created global services that are not necessarily bound to an individual machine. So for example, the storage mechanism behind that, well, first of all, the actual format of it is going to be a columnar store, so all the things around compression and the query characteristics of a columnar format is going to be inherent to this as well. But the storage mechanism is leveraging a lot of the same fundamentals that our global infrastructure does for everything else that we do. So the same paradigms of replication, durability, and storage for BigQuery follows the same things that like YouTube cat videos, Gmail, and everything else that we do does, right? And so that is a highly scalable, highly elastic, kind of you feed it data and it will keep going system. Now on the compute side, when I wrote that query and I hit go, what the optimizer will do is it will essentially say, okay, well, this is what the data looks like in the storage subsystem. This is, the optimizer will say, okay, we think that this query pattern will require XY amount of compute and storage and memory to be able to run this. And then it will automatically spawn that up and then read the data very, very quickly, do the computations, give you the result, and then that compute goes away. This is from a computational standpoint, this is a shared global system. Now there are security mechanisms and software layer protection so that every user is not going to be looking at other people's data or anything like that. So the security is there, But from an infrastructure standpoint, it is kind of like the shared global pool of compute that we have access to, and the environment can just kind of spin up out on its own and be able to execute your query, so that way you don't have to ever think about it. Now that is a combination of the fact that we have lots of computers everywhere all across the world, and connecting the two, we also have a petabit network that's going to be connecting the storage and the compute mechanisms. So when it does spin it up and it reads the data, whether it's terabytes, petabytes, or gigabytes, it's going to do that very quickly into the compute layer, do all that, spin it up, and then you're done with it. So that's how the two also, you're not responsible for compute because it's going to be spun down on its own, and the storage is always going to be completely separated from that.
That's actually also a feature of other databases in the portfolio. So if you've heard of Spanner, it's intentional that they're separated so you can actually scale out the compute based on your needs. And I think it probably applies to a few other database options.
Versus where you have a server and then your compute and storage is bound by that box.
Yeah, I mean, the main reason why I ask is because like Amazon is famous for having like snow solutions, basically hard drives. They even have a truck apparently. I think Google Cloud also would have a truck that goes to vendor places, to customer warehouses, plugs in, picks up all the petabytes of data, and then brings it to the AWS cloud or brings it to the Google Cloud, because putting it over a line or a wire is going to take months. So there is a challenge to be solved there, which I thought maybe you have, because compute separated from data is always going to be challenging when you're talking about petabytes of data.
Yeah, so that is actually part of the, I forget what they've rebranded it recently, I think, so I don't know the exact name, but there is a actual server that we can ship out. So BigQuery, where its performance comes in, is when your data is in BigQuery on the cloud, because that's our infrastructure we can control. That particular mechanism, and other cloud companies have the same thing, but that is to solve the problem of if you have petabytes of data on your on-premises data center and you need to get that into the cloud, that's what bridges it. And then once you're in the cloud, you're off on the express lane, right? So.
I'll just answer your Google Voice question. I think I'll try to answer it quickly. The number one thing I think we provide is reachability. So phone numbers are still the way you do interop. So if you think about how people communicate across companies, or if they're not on the same network, everyone knows each other's phone number. And if you think about how WhatsApp sort of grew in popularity, when you install an app that uses phone numbers as addressability, you get your contacts by your phone number. So even though the transport layer may change, and phone calls have moved from the old copper lines to now over data, phone numbers just provide just an address. So I think that's the main benefit.
So we have time for one more question, and then we'll do a closing question. Sorry, guys.
All right, I got two questions, actually. All right, first one is more like a career culture kind of question. So maybe Ajay, who probably has the longest experience. How do you compare Google now versus when you joined Google, like 8 years? I think I just saw like you guys are like 115,000 people. What has it meant for you as a professional, both from the capabilities that you have access to do your jobs, as well as from a career growth perspective?
I think everyone should answer that question, because you'll get different answers. My answer is, I think definitely the company is bigger. When I joined, I've been in New York my entire career at Google, and the office was really small. We were on one floor, I think 4 in this building, and now we have the whole building. So I used to know a lot more people or just by seeing them when I would walk around the office. But I think largely the culture has stayed pretty open, I think, the entire time, even though the company has scaled. I think the interesting part for me is every time I move, I've worked on maps, on ads, on G Suite. I've worked on a number of different products. I think the one interesting thing is every time you move projects, it almost feels like there's a base layer of infrastructure that's the same, like HR is the same, Google offices look the same, but each organization is slightly different in its culture and how it behaves. So it almost feels like you're going to a new mini company, but you still have like all the infrastructure being the same. So I think that's actually really cool because there's always like new stuff to do when you're kind of like ready to look for a new thing to do. Like you can usually find something internally. And I think Brian and Anu should answer that question also.
Yeah, so I've been here for 6 years, as I mentioned earlier. I have actually had the privilege of working on the West Coast as well as here. And you definitely have a lot more teams, and engineering-wise, we have a lot more infrastructure teams. And I think having so many smart people in the same room allows you to have more opportunities to do interesting, like 20% projects for engineering productivity. You see new people who've been here forever thinking of like different ways to plug into like our code review system and think of interesting ways to like save people time. And then it's really rewarding to do that because you affect so many other engineers at the company. And it's great to see that that's actually grown since I've been here.
And one of the things that I found interesting in contrast to some of the other companies I've worked at were I would look back and typically find that there would be, there's great people in marketing in other companies, great people in sales in other companies, great engineers all across the industry. But I think one of the things that's been a stark difference for me is the integration of them. So I was used to cultures where you would have a sales office somewhere and engineering would be in a different office, and you have different silos, both departmentally and physically in location. And one of the cool things stepping into this building for the first time was the fact that you have engineers, salespeople, marketing people, business operations. Everyone's kind of in that same house, and we're all in the same place. And the culture is definitely one where, by default, your default setting is open and sharing, as opposed to the other way around. So if you want to learn about anything else, if you want to sit down, have a cup of coffee, and just hear about someone else's job or day, like everyone is always going to be up for that. So that it does, it is harkening back to that sort of college campus feel where we're all in this together and we all kind of have that one singular corporate goal, and we're eager to help each other out wherever we can. So that's been fun to see.
Like usually the bureaucracy gets in when you grow. Have you felt that come in at this scale?
I think, and now we're stepping less off company line, and it's just kind of Brian's own musings in his head. But I think with any large company that grows, especially at this pace and at this scale, there are going to have to be controls in place, because you do have to, there does have to be some sense of order to the world. But I think there is a fundamental difference in the mentality and the way that you approach it that is unique to here that I haven't seen anywhere else. And it's growing and still being successful, but still not, it's that old adage of serious without a suit, and keeping that culture intact. And that's ultimately the most important thing. And that's a big differentiator.
All right, thank you.
Yep.
Thank you for your question. Unfortunately, that's all the time we have for questions today. But I'm going to ask the speakers to answer one final one as a closing thought before we go into our reception. What are you most optimistic about in the future of cloud computing? Who wants to go first?
I am actually really excited about all the different ways that we're trying to bring the power, or not to sound too buzzwordy, but things in the cloud space to broader audiences. So for one example, AutoML, you don't have to have a mathematical machine learning background to actually be able to use this machine learning product. This is really big in G Suite. There are a lot of products trying to bring being able to build applications to people with non-traditional engineering backgrounds, and we have different platforms for that way. So expanding who can actually leverage technology.
I'm excited about two things. I'm excited about the experiences that we deliver through products like Google Assistant, and there's a lot of processing that happens to do even things like understanding the many different ways you can ask what the weather is tomorrow. So I think like the amount of computation that we can do to enable these products really excites me. And I think personally, I'm super excited to never have to worry about where my data is, and I switch between probably like 6 or 7 laptops and several phones. So being able to pick up one and just have access to my stuff without worrying about where it is really nice.
I'm honestly more excited about where you all are going to go. I genuinely think just the cloud space in general, and biased opinion, I happen to think that we're the best. But in the cloud computing space as a whole, as an industry, I really do think that whether you look at it from core infrastructure or advanced analytics or anything in between, just as a industry, we're just getting started. And I'm really, I'm most excited to see as a services provider to see what our customers are going to go do with it. I think that customers build really, really cool things on top of these platforms, and that being able to provide the best tools so that you can build the coolest things, that's what I really am excited to look forward to. So.
Well, please give these speakers a round of applause. Thank you very much for your time.